All right, example 6. Find the derivative of the function g of t is equal to t plus 4 over 3t minus 1, all raised to the fourth power. So again, if we're looking at the basic structure of the function t to the fourth power, it's a power structure, right? It'd be 4t cubed and we're done. All right, it'd be easy. In this case, we have a function being raised to the fourth power. So now we have to apply the chain rule to differentiate. But again, the overall structure of the problem is something to a power, so the power rule of differentiation is how we're going to differentiate initially before we apply the chain rule. So I'm going to go g prime of t equals. All right? So if I just apply the power rule to this whole thing, the power is 4, we take the base to the third. So that's the structure of the power rule. That's how the power rule works. The difference between this problem and the problems in section 3.4 is just t to the fourth. Now we have stuff to the fourth, so now the stuff goes in here. And according to the chain rule, since we have something that isn't just t right here, we're then required to multiply by the derivative of this object. That object structure is a quotient, so the quotient rule is necessary to differentiate. So, make my big fraction bar here. Quotient rule says low d high minus high d low over the square of what's below. So low, 3t minus 1, d high, 1, minus high, t plus 4, d low, 3, over the square of what's below, 3t minus 1 squared. All right? T plus 4 over 3t minus 1 is a basic quotient. I took its derivative. So once you take the derivative of a basic function using some calculus technique, you're done doing the chain rule. All right? On Monday, when we see day 3 of the chain rule, we're going to have chains within chains. We're going to have like a composite function embedded within another composite function. So you have to keep chaining along. For right now, you should expect everything just to be the initial problem followed by the derivative, then you're done. All right? So, is everybody comfortable with that step there? Again, power rule because of the power structure, derivative of the quotient using the quotient rule. Then we're going to use algebra to simplify. So we've applied the calculus, we changed g of t to g prime of t. Once we've done the calculus, now we're going to do algebra. It's going to continue to be g prime of t all the way through. I did notice on some of your papers, when I was grading homework, that we were changing t's to x's and stuff like that. Don't do that. Whatever letter they use the letter they use. We're going to start getting, in chapter 3.8, it's called implicit differentiation. We're going to be using several different letters, and we're going to have all those letters within the problem. So keep the letters that are happening in the problem the same. First thing I want to do here, this is a basic structure we're going to see quite often. And there's kind of a way that it differentiates, and there's kind of a nice look to a final answer on these problems. So when you get a problem that looks like this, and you've done the quotient rule to chain it, okay, here's what I want you to do for the next step. I'm going to put 4 over 1 just to create a fractional structure for that, just to establish tops and bottoms. Then I'm going to take this fraction here, instead of having t plus 4 over 3t minus 1 all cubed, I'm going to put t plus 4 on top cubed and 3t minus 1 on the bottom also cubed. This is equivalent to that, but the structure I'm giving you right now is going to lead us to a nicer, more elegant looking answer. And I'm looking for elegance on these answers because I have to grade them, and I don't want to have 8 different answers that are all correct. So I kind of want to lead you guys to what I'm looking for a good answer on this. So whenever you have this quotient to a power object and you get this here, do the calculus first because the chain rule is much easier there. But then go ahead and split that apart. Now when I get to this red piece, the bottom is 3t minus 1 squared. Oops. Okay, and if you just take a look at the bottom, 3t minus 1 cubed, 3t minus 1 squared, hopefully you can start seeing why I wanted to split that apart, because it's not a coincidence that those are going to be the same, because over the square of what's below, these are always going to be the same thing here. So we have the ability to multiply those together using just the power rules, just adding the powers because the bases are the same. Whatever we get on top here is whatever we get. So I've got 1 times 3t, 1 times negative 1, that makes 3t minus 1. I have noticed also in grading people's homeworks that we're not respecting that minus sign sometimes with the quotient rule. Again, there's almost always a binomial or trinomial. There's usually some distributive property happening over here. It's always being subtracted. That minus is attached to this 3 that's being distributed through here. So minus 3 times t is minus 3t. Minus 3 times 4 is minus 12. A lot of you are missing that minus on the 12. All right? And it's not so much on a problem like that, but with the tangents and secants and all that other stuff, I noticed a lot of you had the wrong sign on a term on this side of the quotient rule. So be cautious. That minus sign distributes. If you have to do it in 2 pieces, distribute the 3 first to get this, and then distribute the minus sign, minus 3t minus 12. If you need to do it in 2 steps, fine. But make sure that you're respecting that minus sign. It's almost always minus some group, so be careful that that distribution happens. So what we end up with here, 3t minus 3t cancels. So altogether, g prime of t now, I've still got my 4 over 1 being multiplied by my t plus 4 cubed over 3t minus 1 cubed. It's being multiplied by, that's negative 13 on top over 3t minus 1 squared. So if I simplify that out the rest of the way, looking at the tops and bottoms individually, 4 times negative 13 is negative 52, which is being multiplied by t plus 4 cubed. You can't make that any prettier than that. On the bottom, 3t minus 1 to the third, 3t minus 1 to the second, makes 3t minus 1 to the fifth. That's all being multiplied by 1, which doesn't have to be written. And there is that elegant solution I'm talking about, getting a nice, pleasant-looking derivative here. On your quiz involving this, and also test involving this, that's one of the chain rule problems, a problem of that structure. Quotient raised to a power, the power rule to differentiate, the quotient rule to do the chain rule, and then you're going to get something looking like this on a final answer. So I'm not expecting you to get down to this level for full credit. If you get me some other version of the right answer that's not wrong, but just it's not as elegant as that, I'll probably take off a point or two for not simplifying it well enough.